Okay, welcome back to Study With Me, the series where I go over my AP classes for my AP exams. Before I start, I will be taking a break this Wednesday, because I didn't bring my English stuff with me, so, I won't have time to record the, English portion either, so I think I might just skip English anyway, because the test is so much farther out. Yeah. Alright. Starting with Chapter 3 for AP Calculus. The derivative of f of x is d times f of x divided by d times x. Or limit of h to 0 of, which is, limit of h to 0 of, f of x plus h, like h in the function, so it's x plus h, in f minus f of x over h. The right-hand derivative is the same as above, but it's literally just the right and left-hand derivatives. If function f of x is continuous at the point x equals a, and the right-hand derivative and the left-hand derivative are equal to each other at this point, then the function of f of x is differentiable. The tangent line to the curve y equals f of x at the point p a f of a, is the line through p with slope. So the slope equals limit of x to a, is f of x minus f of a divided by x minus a. I don't know what else I need to say for this. Differentiability. Differentiability implies continuity. So if it's not continuous, you're not able to differentiate it. Sorry. The intermediate volume theorem. Jesus. For derivatives. If a and b are 2 points on an interval of which f of x is differentiable, then the derivative of f of x takes on every value between the derivative of fa and the derivative of f of b. So how f of x, or the derivative of f of x, may fail to exist if there's a discontinuity. Oh my gosh, I'm gonna crash out. I can't talk. A corner point, a cusp, or a vertical tangent. That's all differentiation rules and things, which I think I've gone over. If not, just look up the rules. They're not going to be hard to find. Jeez. Okay, so velocity and other rates of change. Position, easy to remember. Displacement, so you just take the position, like goodness gracious. The higher, like the larger position, and you subtract it by the smaller one. Total distance is distance 1, the absolute value of distance 1 plus the absolute value of distance 2. Velocity is the derivative. Speed is velocity, the absolute value of velocity. And then acceleration is the second derivative. I don't know if there's anything else in here. Nope, doesn't look like it. Implicit differentiation, I don't know how to explain. You kind of just, like, do it. That sounds so bad. But, like, you just factor and then you multiply by the derivative of y on both sides. I don't know how to explain it. It's like you either know how to do it or you don't. I'd suggest looking that up on your own time. Alright. Chapter 4. The absolute maximum value of f is... What? Let C be a number in the domain D of function f. Then f of C is the absolute maximum value of f on D if f of C is greater than or equal to f of x for all of x. And then absolute minimum value of f on D if f of C is less than or equal to f of x. The local maximum value of f if the number f of C... Okay, so local minimum and local maximum are basically the same thing, but they're not. They're just the biggest in that section, not necessarily the whole function. There can be multiple local minimums or maximums. So the derivatives are slopes of the points. So if the derivative of f of x is larger than or is greater than 0, then it's increasing, and then it's the opposite. It's decreasing if it's less than 0. I feel like that's just common sense. Rolle's theorem. Let f be a function that satisfies the following 3 hypotheses. F is continuous. F is differentiable. And f of a equals f of b. Then there's a number c in a to b. So, yeah. The mean value theorem. Let f be a function that satisfies the following hypotheses. F is continuous. F is differentiable. Then there's a number c. That the derivative of f of c equals f of b minus f of a over b minus a. I don't know if there's anything else in here. Concavity, so if the graph is above tangent lines, then it is concave up, and if it was below, it's concave down. I think that's it for this. Okay, optimization. And it's literally just a list, so it should be easy to explain. First, you want to assign variables to all given quantities. Then you want to write a connection equation if it's necessary. Then write a primary equation for the variable that needs to be maximized or minimized. Reduce the right side of this primary equation to one having a single variable. Take the derivative of the primary equation. Find the local minima or maxima. Plug local minima or maxima and endpoints into primary equation to find the absolute minimum or maximum, and then reread the problem to make sure you answer the question that is asked. Moving on to chapter 5, Riemann sums. So you want to divide the interval into equal subintervals. And then the left Riemann sum is when you do the point, you go to the point, and then you go to the right. So, like, you go from the beginning point to the right. And then for the right Riemann sums, you go from the beginning point up. No, wait, what? So, I don't know how to explain this verbally, but for the left Riemann sums, you go up until you reach the point on the beginning portion, and then you go to the right with the little box thing. And then for the right Riemann sum, you go all the way up till the end of the next point, and then you go to the right. Don't ask me. I really don't know how to explain that verbally. Then the midpoint is the middle part of the function should reach the graph. I don't think we really do that, so I don't need to explain it. Excuse me. Integration, which once again you can just easily find the rules on that if you don't know them, but I'm pretty sure I've stated them before. Population growth. I'm gonna be so real, I don't know how to do population growth, but you take dp over dt equals kp, and k is the relative growth, and then p equals p0 ekt. I don't know. Find the relative growth rate. Okay. Logistic growth model, dp over dt equals k over mp multiplied by m minus p, or dp over dt equals kp multiplied by 1 minus pm, or p over m, sorry. Yeah, I don't really know how to do that. Sorry. Fundamental theorem. If f is continuous, then the function g is defined by g of x is a to x, or the integral a to x of ft dt. Yeah, so that basically just makes g of x the derivative of f of t. This is not really important. Area. I think I did skip 6. Yeah, I skipped 6. Okay. So chapter 7, area between curves. The area equals the integral of a to b of fx minus gx dx. And then volume is basically just the same thing, but it's multiplied by pi. So the integral itself is multiplied by pi. So, yeah. Now we're at chapter 8. Yeah, and then we're done. So this was a really short episode, I guess. So limit from x to a fx over gx equals limit of x to a of the derivative of fx divided by the derivative of gx. I think that's it. Yeah, because some of this I can't just verbally explain. So I think, trying to think. I think next time, or not next time, sorry. When I have the chance to, maybe, like, when I'm done with, actually, like, for real done with this series, I might do either A, video, or B, a live stream where I do FRQs. Or, like, try to figure things out on stream, because I think that would be easier for me to do. Because that way you guys can actually, like, see what I'm doing. You know what I mean? Like, I don't want to just sit here and just yap and be like, oh, do this, do that, when I've never shown myself, actually, like, trying to solve a problem in front of the camera. So I think that's what I'm gonna end up doing. I'm sorry this video is so short, but if y'all have any questions, feel free to ask me, because I will try my best to answer, and if I feel like I can't answer them, I might ask my calc teacher, when I see her Monday, or when this video comes out. No, I will most likely ask her Thursday, because, that is when trying to think, that is when I go after school to, like, talk to her and get help. So, yeah, just remember that I am not doing too hot in this class specifically. So if you are struggling, it's probably best that if you need the extra help, go find other videos on YouTube with people who are smarter than I am when it comes to this. But I think I'm getting better, because I just got a pretty decent grade on my test recently. So if you do want help from me, leave a comment, ask a question, whatever you feel like you need help with. I will say this right now, though. The FRQs are the absolute enemy. Like, they are the bane of my existence, and I will try to figure out the ways of grading them, so that way you guys have, like, you can understand, like, how it all works and whatnot. But from as far as I'm aware with these FRQs, I'm trying to think. I'm sorry, my brain's not working as of recent. As far as I'm aware, most FRQs can have up to, like, I want to say 6 points, more or less. It really depends on the FRQ, and it really depends on the subject material. So, yeah. I think that as long as you are showing your work, because even for the calculator-based FRQs, they want you to show some work And even if you show work, you're more likely to get points than just writing the answer. Because I have done FRQs in the past in my class that I didn't get any points because even though I got the right answer, I didn't show work. So please show your work. I know it's stupid, but they just want to make sure you understand the material. For the multiple choice questions, like any other test, if you don't know the answer, just guess. It's better to have a possible right answer than no answer at all. So I think that you should just learn your integral rules, learn your differentiation rules, which I do have here also, so I may reread those. Hold on. Let me pull those out real quick. Also learn your unit circle. That's a little harder to read out loud though, so I'm not going to read that out loud. Jesus. But yeah. Okay, so differentiation, if it's just a constant or a real number, it equals zero. Oh my gosh. If you differentiate x of n, it'll equal n times x to the power of n minus 1. E of x will just remain e of x. Sine of x will equal cosine of x. Cosine of x will equal negative sine of x. Tangent of x will equal secant squared of x. Cotangent will equal cosecant or negative cosecant squared of x. Ln of x will equal 1 over x. Arc sine will be 1 over the square root of 1 minus x squared. Arc cosine will be the same thing but negative. Arc tangent will be 1 over x squared plus 1. Arc cotangent will be the same but negative. The actual rules, plus and minus, just look how they would be like the derivative. That's the word I was looking for earlier. I'm sorry. The derivative of u plus v, like if they're both in the derivative, it would be derivative of u plus v, or derivative of v. Then multiplication is the derivative of u times v plus u times the derivative of v. U over v would be the derivative of u times v minus u times the derivative of v over v squared. I think that one's pretty obvious. Okay. Integration. The integral of a dx is ax plus c. The integral of x to the power of n dx is x to the power of n plus 1 over n plus 1 plus c. The integral of 1 over x dx equals ln of the absolute value of x plus c. The integral of secant squared x dx equals tangent x plus c. The integral of cosecant squared x dx equals negative cotangent x plus c. The integral of e to the power of x dx equals e to the power of x plus c. Those are, you don't really need to know. But yeah, that is about all I'd say. Sorry this video is a little shorter than usual, like I said before. I think that is all I can really cover, because that's all I really know, to be completely honest. next video of AP Calculus will either be, trying to think, will either be it might be a video, it might be a, live stream, but I might just post the live stream if I do a live stream, but it's just going to be FRQs, applying what we know, stuff like that. It's not really going to be like anything special, but yeah, that is all we have to cover for notes in AP Calculus. I hope you all learned something, and if you didn't, I apologize. It was really short and not that, like, helpful, probably, but hopefully, if we do FRQs, if and when, it'll make more sense. But yeah, that is all I have to say for now. So I hope y'all had a great day. Hope you learned something. Hope you do well on your exams if you're taking any. Bye.